Assalamu alaikum. How are you, Professor? My name is Ayaz Final, and today I'm going to show the simulation part of the thesis I have done. Here, as I'm showing in the thesis report, the normal typical charger circuit consists of AC source, AC voltage source, transformer, rectifier circuit, voltage regulator, auto cut-off arrangement, and a battery. Now I'm gonna show the circuit here. The values that we have found is discussed in detail here in this pages, and today I'm just gonna show the results. So this is our voltage source, which gives us 230 volt, 50 hertz AC signal. So we can see it here. Here 230 volt, and in this part, after feeding it to a transformer, we convert it to 20 volt voltage signal, and after that we are feeding it to a full bridge rectifier with a smoothing capacitor, and in the output we are gonna see like that the sinus signal that is coming out from here is somehow came to a DC signal. After that, we just have a stable output here. We connect this signal to an LM317, and after that, the output of this component will be like 13.5 or 14 volt, and will be fed to the battery. Like you can see here, the voltage out here, and this is the voltage of the battery while charging up, and this is the current of the battery. So after finishing the charger circuit, I just designed the auto cut-off arrangement circuit where the energy will be cut when the battery become full charge. So the algorithm which this part of the circuit works just discussed in detail in this part. So when we come to the simulation, as we said here, when the voltage of the battery is 12.9 volts when it's fully charged. So our relay should work when the voltage become like 12.9, and if it is lower than that, it's gonna charge the circuit. So it's normally connected, which means that when the switch is like this, the battery will be charging, and when it become fully charged, the switch will become to the open, like to this position, which is the open circuit. But because in simulation, like the voltage will be constant, since we have an ideal voltage source right here, so I just disconnected this part to show that the relay will be activated whenever the voltage becomes like 12.9. So when we power the circuit, the voltage, as we see here, the voltage is 12.6, but the relay is working and the battery is charging right now. So if we just increase the voltage here, the voltage across the battery, we see like 12.7 is still not working, and when it becomes 12.9, the relay now just disconnected the battery from the system. So now the battery is not being charged. So by that we can save the battery from overcharging, and whenever the voltage of the battery become lower than that, it will restart to being charged. Now we came finally to the final part of the project, where the 12 volt battery is connected to an inverter to transfer the 12 volt DC to 230 volt AC. The designing information is given here, and if we look to the circuit, we can see here this is the part where the bipolar scheme is done. Like we can see here the carrier signal, which has 5 kilohertz frequency, and this is the normal signal or sampling signal, which have an amplitude for 1 volt approximately. And then the two signals is compared and then fed to the gate of the IGBT, and then the output square signal, which have 24 volt peak to peak, is fed to a transformer which converts it to 230 volt AC. After that, after this transformer, we have 230 volt square wave AC. So by using LC filter, as we see here, we convert it to a sinusoidal signal which has an amplitude of 230 volts. And this is the loud, which has on. Like we power the system, we can see that we have 235 volts, like for phase to ground voltage. And if we look at the phase to phase voltage, we can see that it is like 400 volts, 405 volts approximately. And by that, I finalized the project. Thank you, sir, very much for your patience, and may God bless you. Have a good day.